focus on the hazards, or we can focus on the resilience of the things that are affected by the hazards. So let me briefly talk about the first approach, but concentrate more on the second approach. So if we are focusing on the hazards, we have to focus on differences, because different hazards will have different features. Of course, the infrastructure that it affects are similar, but you have to focus on the different hazards. At the same time, you can focus on some similarities, because the approach to dealing with hazards involves similar ideas. For example, you need to have hazard zones. You need to see whether natural mitigation can be utilized. You can see whether no-build regulations have to be imposed. And for each one of them, say for example, you need to see whether proper guidelines for non-engineered buildings have been presented or have been developed. Now, these are, for example, some of the things that we did when I was chairing a subcommittee at the Disaster Management Center. So we tried to get some of these zonings, update some of the wind speed zonings for the country, and also try to develop some earthquake zonings for the country. So whether it is an earthquake or whether it is a cyclone, we need to have zoning. Then also, these are some of the definitions of different hazard zones. So once again, we have high hazard, medium, low, and no hazard. And we can define different geographical areas of the country. For example, where coastal floods are concerned, it will mostly have to do with distance from the coast. Where things like cyclones and high winds and landslides are concerned, they will be defined in different ways. So we can see that when we are dealing with hazards, when we are focusing on the hazard, it is useful to use templates like this. Now, this is another template that was developed. So, for example, these are mostly for buildings. For each of these different types of hazards, we can try to see whether the features that are desirable, whether they are just recommended or whether they are in fact mandatory. That is the kind of approach that we can use when we are looking at hazards. So we look at the different hazards, but we try to deal with all of them in a similar way, in the sense that we make sure every aspect is covered for all of these hazards. Now, when we focus on resilience, it's a bit different. Now, this word resilience, of course, is used in many contexts. In ecosystems, where social resilience is concerned, economic resilience, which we are thinking about right now during COVID, and of course, resilience against natural disasters. But the word resilience actually has a structural mechanics root. Resilience, as was used in the early 19th century by the people who were developing structural mechanics, had to do with the area under the stress strain curve, the amount of energy that can be absorbed. Now, these are some things that I have done in the past about it, where I argue actually that we should think more about toughness, because when a material is ductile, it can absorb energy even in this plastic region in this way. Now, what we are trying to do, what I'm going to present, is a structural mechanics analogy that will help us to define and perhaps even quantify resilience. Now, structures are resilient if they are redundant, meaning they have more members than they need. If they are well formed, meaning that if their loads can be shared roughly equally between the members. And if they are ductile, meaning once it reaches its maximum load carrying capacity, it does not fail suddenly but maintains the load, and any increasing load can be shed onto other members that are close by. So, interestingly, when the World Economic Forum looked at a much wider set of systems, economic, environmental, governance, etc., they used the same words, almost the same words, to define what the characteristics of resilience were: robustness, redundancy, and resourcefulness, which is similar to what I call ductility. And this is about resilience performance, that is the response to a disaster and also the recovery from the disaster. But what we are trying to say is, I'm trying to take these ideas, robustness, redundancy, and ductility, and broaden its application. So when we are talking about the resilience, which I'm going to concentrate now of infrastructures, we must make sure that infrastructure is well shared. We must make sure that infrastructure has extra capacity to deal with some sudden demands on it. And we must make sure that infrastructure is able to adapt to unforeseen situations. So resilience is made up of these three components. And so, for example, you can use these ideas to plan some kind of resilience audit. So you can do it at a building level, a city level, a country level, but at each, and for these different components from infrastructure to geopolitical. But for each one of those, we need to see, are the robustness components okay, good sharing, are the redundant components okay, alternatives, and is the ductility also okay, ability to cope when situations are a bit different or there is a greater demand than normal. Now, I'm not going to go into this in detail, but you can actually calculate the energy under these curves. Use this structural mechanics analogy. This has already been published elsewhere. And then you can try to estimate the different energy absorbing capacities for these different configurations. So this is a trade-off between redundancy and ductility. We can see that even though the redundancy is low, you can have high energy absorbing capacities if the ductility is high, and vice versa here. Low ductility, high redundancy also means that you can have high energy absorption. If you have both, of course, you have very high energy absorption capacity, right? Now, this is an example of that spelled out in some infrastructure in Kuala Lumpur. Now, this tunnel that you can see is actually a road tunnel, but it is called a stormwater management and road tunnel, smart tunnel. So when there is no storm, it is only the vehicles that use this tunnel. Occasionally, maybe once a year during the rainy period, you have some heavy rainwater that has to be conveyed, and that can be conveyed under this kind of, in this drain that is under this roadways like this. But if you have maybe a once in 50-year storm or something like that, then you have to close this tunnel to traffic, and then you have to use it only for the water. So you can see that this is an expression of ductility. The tunnel behaves in a particular way under normal loads, but when the loads are exceeded, say this is the normal load, water load, but when the load is exceeded, then it behaves in a different way. Of course, some inconvenience caused, but the important thing is you do not need to build two tunnels, one for the rainwater, one for the vehicles. You can manage with one component. So you are trading off redundancy. You do not have redundancy because you have this ductile way of behavior, ability to adapt. Now, this is just north of where I live. So if I want to go into Colombo on a morning, a weekday morning, I have to go through a situation where there are 3 lanes of traffic going northbound like this. And this lane is on the other side of this center island as well. That is because for rush hour traffic, one side of the road is not enough. So here you find that this road is behaving in a ductile manner. It is behaving differently when there is rush hour. Southbound, there is only one lane in this direction. So if you look at the map here, you find that here from this Dehiwala junction up to just near this Dehiwala bridge, you have only one road that can take you into Colombo, and that gets overcrowded. So in those situations, we need to have the infrastructure behaving in a ductile manner. Once you pass this, of course, there is both this marine drive as well as what we call this gold road that can take you into Colombo. So there are no 3 lanes of traffic here. So here there is redundancy, here there is ductility. You can interchange these, and if you are planning infrastructure, you need to take these kinds of things into account. Now, if you think on a bigger scale where the roads in Sri Lanka are concerned, now here this is the coastal road severely damaged during the 2004 tsunami. It is impossible to defend this road against that kind of event. Fortunately, we had already planned a southern expressway like this. So this is another road that connects the capital city to the south of the country, and it must be appreciated that this southwest quadrant and these coastal areas in the southwest quadrant are where the most of the development in the country has taken place, and that needs to be well connected to the capital city of Colombo. So based on what I was talking about earlier, we can even come up with some kind of resilience scale that goes from 1 to 8. Now this work is continuing. I have a student who is working on it. These are some very preliminary results, and I have not even checked his work. But we can come up with the resilience index between 1 and 8 for different cities in this kind of way with respect to infrastructure resilience, environmental resilience, and social resilience. As you can see, Colombo doesn't do too well here. Maybe it's too crowded. Which brings me on to my next slide. Colombo is very, very big. So if you think about Colombo and the rest of the cities, and if you draw a graph between the log of rank, now this is number 1, 2, 3, 4, 5 like this, and the log of population in those cities, then you get a curve that is concave upwards. So which means that this is dominating severely. Now, if you look at India, it's actually convex upwards in this kind of way, right? So India has many cities that can, in a sense, so they don't have all their eggs in one basket, so to speak. Now, you can look at this in a different way as well. So this is when you have the biggest city, the next biggest, actually the next biggest, Dehibala Mount Lavinia, is not really a separate city. It is connected to Colombo. It is actually Greater Colombo. Now what we can do is, now there is this thing called Zipf's law, which says that if you take the log of rank and the log of population, or the, you know, this can be many other entities like this, then it should fall on a straight line. Now what I have done is try to plot this on a straight line without plotting rank number 1, right? So when you plot it like this, this is the indication of where rank number 1 should fall. But actually rank number 1 Colombo, its logarithm of population takes it up here. So I can calculate something called a degree of primacy. And it is, you know, this is called a primate city. Colombo is a primate city. If you take Colombo and suburbs together, the degree of primacy increases to 4.6 from 1.9. So you can see we have stored all our eggs in this one basket of Colombo. Now, is that good? Can we think of alternatives? So let me try to explain this in a different way. Okay, so if you think about Colombo like this, you can think that, okay, we have had many disturbances in our country, many problems in our country. Now, those problems have had many reasons, socio-cultural, socio-ethnic, you can call all of them, right? And they have various reasons, maybe an economic reason, maybe some kind of ethnic reason. But another way of thinking about it is that all of these problems arose in areas that are furthest away from the city of Colombo. What if Colombo, the capital city, was situated somewhere close to the center of the country? Also, we have to we understand that Colombo is a coastal city, subject to things like coastal flooding, tsunamis, and various things like that. There is also a nuclear reactor at the tip of India, somewhere like this. It may be good to think about an alternative city, a second big city perhaps. Now this is just speculation, just putting out some ideas, somewhere near the center of the country. How do we find out where that is? Well, I want to have a small diversion here, also connected to resilience. It's to do with connectedness. And we can use some of Newman's theories to find out what the most connected link is. Now, if you think about this kind of system, we can do the calculations and find that this link 3 to 5 is the most connected in this network. If you break this, then you are doing the most damage to this network. Now you can do that to things like, you know, structural assemblies like this. Most people, when they design trusses, they only think about the stress and whether the members have enough strength to carry that stress. But here, this is a way of looking at connectedness as well. So we would argue that this trust is better than this trust, because the members that are most connected, are the ones that are inside like this, right? Whereas here, if you lose this member, you have lost a cord member, and that will considerably weaken the trust. Now you can apply this to a road network as well. And if you do this to Sri Lanka's road network, the most connected road link is the A6 and A9 overlap at Dambulla. That means most of the traffic in the country, the greatest amount of traffic in the country, not traffic so much as the route, in order to get from one place to another, will tend to pass this overlapping roads. So this is the area. So this is the A6 that is going in this direction, and this is the A9 that is going in this direction, and this is the stretch that we are talking about, right? So the idea is that if this is the one that is most connected to most parts of the country, could we not have a capital city here? We look at the National Physical Planning Department's metro areas, and we find that one metro area is somewhere here as well. We find a paper by Professor Madhuma Bandara in 1992. Of course, he's, I think, proposing Anuradhapura as a capital city. This area that I'm suggesting, Dambulla, is not too far away. Of course, I do not have any clear plans, but I'm saying that we can use some of these ideas about resilience and robustness and connectedness to think about the way that we think about national resilience over the next 20 or 30 years. So let me conclude. There are two ways to think about resilience, like I said. One is to focus on the hazard. And in that, a very useful thing to do is to have templates to make sure that you deal with every hazard in a similar way, so that you fill in all the gaps and don't leave anything unturned. Don't forget anything. The other way is to focus on resilience, where you do not think so much about individual hazards, but you think about the entire system, the entire infrastructure, the entire country. Is there robustness? Is there redundancy? Is there ductility? Ductility is a very important concept. It behaves in one way during normal situations. It is able to adapt and behave in a different way when there are unforeseen loads or stress or demand on that situation. And seeking trade-offs between redundancy and ductility, and also explore connectivity for insights. So I think I will stop there. Thank you very much.
Thank you very much, sir. Now the floor is open for questions. So meanwhile, I would like to ask you about the zoning, and then it is very interesting discussions. So how about the other hazard zoning would make an impact to this proposed argument of changing the capital from Colombo to somewhere else?
Yeah. Okay. Sorry. In the presentation, I talked about changing the capital city. Maybe I should not have said that, but in the slides I have said something about a new big city.
New big city.
I mean, yeah. New big city,
yeah.
Right? Separate from Colombo, because as it is, Colombo is growing larger and larger, and it is just urban spread. Whereas geographically, that may not be the best thing, right? So okay, so you are trying to say, if this city that we are proposing, we should also think about the hazard zones and not only things like road connectivity. You are very correct. Yes, that also has to be taken into consideration. Maybe I should have done that, but actually I think an area like Dambulla probably is okay, because I think it misses the cyclone belt, which goes probably north of it, and of course it is off the coast, so that means there are no coastal hazards. I'm not sure how it squares with the earthquake map, but actually speaking, there isn't very much difference in earthquake acceleration throughout the country. But certainly, thank you. That's a good question. Yes.
Yeah. So the other question would be from my side, like there is a historical history behind this development of the capitals, I guess, like the near it being near to the coastline and then approached by the overseas, like through the ports and like the transport of goods and services, maybe. So how
Yeah.
what would happen to that, like from like when you are connecting via from the over other countries? So
Yeah.
what like.
Yeah, yeah, once again a good question. So that's why I said maybe what I said was slightly misleading in referring it to as a capital city, right? Now there are other people who are proposing that we should have many smaller cities being developed, right? So maybe this megapolis ministry at one time, I think that was also part of their plan to enhance the urban environments in not only in Colombo and the Western Province but in other parts as well, right? So I respect that, and I respect the urban planners who talk about developing smaller towns. I'm just wondering whether to make an impact, whether you need to have really another large city, because otherwise there's a lot of urban drift into Colombo, a lot of urban drift. So if we can have two cities, I mean, it's just sort of a provocative idea.
Yeah.
On the other hand, you could argue that the country is too small to have two large cities. But I would certainly like to put this out there for discussion for
Yeah.
people to think about it and engage with it. Yeah.
I always like the when I even I meet you in person, like I really like how you trying to integrate these concepts of structural engineering into the disaster risk management, and then to like it's like kind of broadening the knowledge base, and then also like thinking, like challenging us to think more about these things rather than looking into this conventional thinking of hazards and then exposure, and in this conventional the theories of disaster risk management. So there are several questions from the participants in the from the Zoom. So one quick question one would be, have you tested the robustness and connectivity for the early warning system in Sri Lanka?
Right. I think there has been some work done on this. I have not done any work on this. I think our chairman of this particular panel has done something on social network analysis, I think, or
Yeah.
something. I think so that would have something to do with connectivity.
Yeah.
So I'm aware that some work has been done. I have not directly been responsible for it, but yes. So, what I'm proposing also ties in a sense, through the idea of connectivity. Yes. Yeah.
So the second question is, in an era of cascading disasters, what is your take on dynamic resilience and how new innovative tools can be used to redress it?
Yes, okay. So, I mean, here also there has been some work done on it. I do not claim that I have been part of it, but so we are talking about basically what I would understand by your question is that we have certain values, if you want, for robustness, redundancy, and ductility, and those numbers will change through the cascading disasters. Yeah, I am not sure about what the best tools are, but I think there's a lot of development that would be required. Thank you for the question. Great question. Yes.
The question number 3 is like very interesting question, sir. Like the other question is how to seek a trade-off between redundancy and ductility. Please explain.
Yes. I can see that the same person has asked what is the way to explore ductility. So I will answer both of those questions if that's okay. Yeah. So I think that smart tunnel in Malaysia, I haven't actually seen it, right? It's been written up. So I'm taking the information from what's being written up. I think that's a good example, and I have seen a few examples of it elsewhere in the world. Also, mostly to do with floodwaters, actually, right? Mostly to do with floodwaters. So the floodwaters occur only occasionally, right? and we need to be able to use some of those areas for other types of activities, which of course will need to be suspended when your 25 or 50-year flood comes along, right? So that tunnel is one example of that. I try to give a few other examples in my talk also, like just the way that the traffic is controlled in rush hour, just close to my house. People are moving it so that you don't need to then build another road. I mean, you can use just a single road, but you can use it in a different way during rush hour and during the normal traffic. Yeah. So this has to do with reducing the costs of infrastructure, because countries are finding it increasingly difficult to find money to put up infrastructure. So the idea is to use it in a better way. I hope that question and I hope that answer is okay.
Yeah.
Right.
So there is another question. When are we going to have resilient cities? Resilient cities. Do you think that we are, as a country, somewhat backward in terms of new technology and innovative thinking in terms of robustness, redundancy, and ductility? So, what do you think about that?
Well, I mean, the thing is, sometimes, these things happen in a sense almost by accident. I mean, without thinking about it. I mean, okay, just the example of once again that road that is used with 3 lanes going northbound and one going southbound in the morning. So because of the exigency of that situation, the traffic police probably thought of doing it in that way, right? So then, when we take steps in situations, we need to see, what have we learned from this experience? Is this a positive experience? And can we translate this experience to other areas, completely different areas, but conceptually see it as an example of ductility? I think that's what we need to do. And no, I haven't said anything about COVID-19, but there are a lot of things that have, occurred due to COVID-19. And I think we can say, okay, what are the, robustness, redundancy, and resilience and ductility examples we have learned from it, and see whether we can replicate some of those things in other areas also. So, I am using this structural mechanics analogy, and my sort of theoretical position is that it can help us to analyze many situations. So that's the position I'm taking. I'm sure there are shortcomings in that framework, but I think it's a reasonable framework for exploration. Yes.
Yes, I think we are like almost running out of time. So one last question, sir. In embedding these resilience characteristics, what do you think? What do you see as the main barriers in Sri Lanka? Like embedding these resilience characteristics maybe into policy planning and decision making. I would.
Yes. Yeah. I don't know. I think we need to have some kind of evidence-based analysis, evidence-based research. Maybe if these interventions are done, some kind of analysis of how good or otherwise they are. Sometimes perhaps now, just like this conference is trying to do, sort of links between what is coming out of universities, because universities are always thinking about funny ideas, right? Like the one that I presented just now. So most university people will think about things like that, because they need to focus on originality. But some of those things may be useful, and therefore planning ministries and people like that need to have their eyes and ears open, and link up with ideas coming out at university. So I think this conference is doing a great job. Yeah.
Yeah. So thank you very much, sir. And then, as you correctly said, it is like always. It is very important to mainstreaming these things and embedding them into the like planning and decision making. Also, I guess. So then, as you said, it is always very important for the scientists and then the practitioners and then the policymakers coming together and have a open, honest dialogue. Sir, is there any concluding remarks from your side before we conclude the session?
No, I think, I would like to do, think about what I said basically, and see whether, it would be great to see whether if there are any other examples about, how this, has been implemented or whatever. I will stop there. Thank you.
Thank you very much, sir, and please continue your thinking, and then please pushing us to do better. And with that, we are concluding the final keynote, and then we will be moving into the technical sessions. And thank you very much, Professor Priyan Dias from University of Moratuwa, for his keynote speech. Thank you very much.